Alright, so our first topic is coordinate geometry, which is basically looking at graphs, coordinate axes, points on coordinate axes, and how all these different things interact. So from your GCSE, you probably remember the equation y equals mx plus c. And hopefully you can remember what each of these means. So y is our y coordinate, x is our x coordinate, m is our gradient, and c is our y-intercept. So just to kind of demonstrate that, if we plot graph of y equals 5x minus 2, it means that we're going to have a gradient of 5 and a y-intercept of minus 2. So let's quickly try and sketch that. So set of axes. We know it's going to have a gradient of 5, so that means it's going to be quite a steep line. We can think a gradient of 1 is just this line y equals x. So gradient of 5 has got to be 5 times steeper than that. And we know its y-intercept is minus 2, so it's going to cross the y-axis. I should label these really, y and x. So it'll cross the y-axis at minus 2. So let's put that point in there, minus 2. We know it's got to be quite a steep line, so something like that. Not the straightest line, but that will do the job. Alright, so first thing we want to look at is, if I give you guys some different equations of lines, I want you to be able to try and work out what the gradient is and what the y-intercept is. And you can only do that when the equation is in this form. So you have to rearrange, get the equation to look like y equals a function of x plus minus c, whatever it is. Rearrange to get y equals, and then you can read off what the gradient and the y-intercept are. So we'll start with that. Alright, so example 1, we'll have 2y equals 6x plus 5. And example 2, we'll have 3y plus 6x minus 3 equals 0. So if you could pause the video quickly, I want you guys to try and rearrange these to get them in the form y equals, and then write down what the gradient and the y-intercept are. So pause the video now and try and do that. Alright, so how are we going to do this? Well, we need to rearrange it. So at the moment we've got 2y here, so we need to divide everything on this side of the equation by 2. So divided by 2, we're going to get y equals 3x plus 5 over 2. So in A-level maths, we like to keep things as fractions most of the time. It's because it's easier to manipulate and do mental maths with fractions, to try and keep things as fractions. So for this line, the gradient is 3, and the y-intercept is 5 over 2, which we know is 2.5. And for the second question, so for this one, two kind of problems. We need to divide everything by 3 to get y, and then we also need to take these terms over to the other side of the equation. So let's do that first of all. So we'll say 3y equals, take this 6 over, so minus 6x. And to get this minus 3 over here, we need to add 3 to both sides, so we have minus 6x plus 3. So I move both of these terms over here. Now we're going to divide 3 by 3, so we get y equals minus 2x plus 1. So again, our gradient for this one is minus 2. And our y-intercept is 1. Brilliant. Okay. Good. Alright, if you want any more practice on these, page 92, question 1, 2, and 3 is a lot more examples of this, but there will be some but there will be some in the textbook and on the Moodle questions and in the weekly test as well. So you will see these again, but if you want some more practice, there you go. Alright, next up we're going to talk a bit more about gradients, because they're a really important part of this course. Alright, again, I want you to pause the video and have a quick think about what a gradient actually is. If you had to describe to somebody who'd never heard of the word gradient, what would you say? What is a gradient? Okay, so hopefully you've come up with something like rate of change with respect to x. You might have said something like it's a measure of steepness because it tells you how steep a line is. So that gradient is greater than that gradient. We could also say this gradient is negative. So 3 different kinds of gradients on those lines there. But what we actually mean is how y is changing when we change x. So if you move along by 1 unit in the x-axis, what happens to y? Does y go up? Does y go up by a lot? Does y go down? Is it positive or negative gradient? Is it a steep gradient or a shallow gradient? So we're talking about how y changes with x. So in kind of plain language, we could say how much y increases or decreases for every unit increase in x. So for every 1x you go up, what happens to y? Does it increase or decrease? And you might have seen at school, you might have come up with the equation, what pen brush should I use? You might have seen the gradient, we call m usually, so m is just a symbol for the gradient, equals, maybe you had rise over run. You might have called it rise over step. Some of you might have used these little delta symbols, so you can have delta y over delta x, and that means change in y over change in x. Or we can then put that in words and say it's the difference in y divided by difference in x. So amount of y change per amount of x change. So in A-level maths, we've got an equation that we're going to use to calculate what the gradient actually is. So if we get rid of this a sec. And really, we're just talking about a different way of using these equations. It's these equations, but with actual numerical values in them. Right, it's time for another sketch. So if you've got a set of axes, and let's put just a random line on here. Something like that. So we're going to now pick 2 points on this line. So 1 point here, another point here. So this point we're going to call point 1. This point we're going to call point 2. And point 1 has an x coordinate and a y coordinate. So you can see x coordinate here and y coordinate here. And we're going to write these as coordinates in brackets. So we're going to say coordinate 1, the x coordinate, call it x1. And the y coordinate we're going to call y1. So this point is at x1, y1. Okay, we're going to do the same thing over here. So point 2, so we're going to do the same and say this is x2, y2. And the gradient of this line is going to be the difference in these y values. So I can draw that on as well. So it's the difference in the y's, y2 take y1, divided by the difference in the x's, which is going to be x2 take x1. So we can say the gradient is y2 take y1 over x2 take x1. And that is one of the most important equations that we have this year, so make sure you memorise that one. But all it's saying, difference in y's divided by the difference in x's. Right, so let's try a few examples of how we're going to calculate these gradients then. Right, example 1, so if you guys could copy this into your notes, find the gradient of the line joining 2 minus 1 So we've got 2 points. We want to find the gradient of the line that joins these two. For this first example, I'm going to sketch it just so you can see what's actually going on. So first point is at 2 minus 1. There's a point. And the other one is at minus 3, 5. So somewhere up there, we've got some kind of a line. Very rough sketch. It doesn't even go through the point. Very rough sketch. We're trying to find the gradient of this line. So we're going to use this equation, and we're going to say, well, this could be point 1, this could be point 2. It doesn't actually matter if you do it the other way around, because all the minus signs will cancel out, and it'll still give you the same gradient either way around you do it. So we're going to do y2 take y1. And for the first few times you do these, it's best if you label them, because it's easy to get your y's and x's mixed up. So remember, the x coordinate comes first, x2, y coordinate second, y2, x1, y1. So if you label these the first few times you do these kind of questions, you'll get less mixed up and you'll be able to remember which coordinates which. So our gradient is going to be y2 take y1, so it's going to be 5 minus, and then we've got a minus here, so it's going to be 5 minus minus 1. So I'll write it out like this for now, but we ought to know that minus is positive. And then x2 minus 3 take away 2. So that's the equation for our gradient. If you're subtracting a negative, it's the same as adding it, so we can write that out a bit more simple. 5 plus 1 over minus 3 minus 2. 5 plus 1 is 6. Minus 3 take 2 is minus 5. So our gradient is minus 6 over 5 for this line. So slightly steeper than minus 1, which, yeah, I've kind of drawn that well-ish in that picture. Right, let's try another one. This time we won't sketch it, we'll just do it with the algebra. So EG2, find the gradient of the line joining 3, 0, and minus 2, 7. So again, label the coordinates, call this one 1, this one 2, doesn't matter which order around. Actually, just do it the other way just to prove that. So we'll call this one point 2 and this one point 1. So again, we're going to put these into this equation up here. So the gradient is y2 take y1. Well, y2 is going to be 0. Take y1, which is going to be 7. Divided by x2, 3. Take away x1, minus 2, so plus 2 there. 0 takes 7, minus 7. And 3 plus 2 is 5. So the gradient of this line is minus 7 over 5. Cool, right, let's try one more example. And it's going to be a harder kind of problem than solving a style example. Which is much more likely to be the kind of question you'll see on an exam. So, example 3. So, we've been told the gradient, we've been told the 2 points, but we've got an unknown constant here. So we're algebraically now going to try and find out what letter D is as a number. So we're going to put everything into our equation, rearrange, and hopefully find out what the value of D is. So if I write out again, so this time we've got the gradient, we know the gradient is minus a quarter. So the gradient equals y2 take y1, so if we say this is 0.2 and this is 0.1, y2, 4, minus y1 is 2d, divided by x2 take x1, x2 is 1, minus x1 is minus 1, so minus is plus 1. Okay, so if we try and simplify this a little bit, we can say minus a quarter is 4 minus 2d divided by 2. We can then times both sides by 2 to to get rid of 2 on this bit. So times that by 2, and we're going to get minus 2 over 4 equals 4 minus 2d. Minus 2 over 4 is just minus a half. So minus a half equals 4 take 2d. Now we could times everything by 2 to get rid of the half. So we're going to get minus 1 equals 8 take 4d. We could now take 8 from each side. So we get minus 9 equals minus 4d. Divide both sides by minus 1, which will give us 9 equals 4d. So d equals 4 over 9. Nope, that's a load of rubbish. D equals 9 over 4. Right, next bit is parallel and perpendicular gradients. So we need to talk about parallel lines and perpendicular lines. So parallel lines look like that. And what can we say about these two? Well, parallel lines have the same gradient. They're rising at the same rate. If one was steeper, they would cross somewhere. But because they're parallel, same rate of increase of y with x. So we can say parallel lines have the same gradients. So gradients are a measure of steepness, as we said earlier. So the steepness or the gradient must be the same for lines to be parallel. Cool, so for example we could have y equals 3x plus 2 and y equals 3x minus 7. So those could be these lines if you want. Y equals 3x plus 2 is here. So that's 2. 3x minus 7 minus 7. So those lines are totally parallel. Okay, perpendicular lines. A little bit more difficult. So we're going to sketch some perpendicular lines. That's not too bad. So put a right angle in there so we know they're perpendicular. So if you guys could again pause the video quickly. Can you decide what a rule would be to do with the gradients of perpendicular lines? So have a think. What rule could we say exists? Parallel lines have the same gradient. What might be the case for these lines? Just looking at what the lines look like. Okay, so you might have come up with one of these has got a positive gradient and one of these has a negative gradient. So I'll put that up as a bullet point. And you might have had a guess about what kind of values they might have. So you might have said, well, maybe they've got the same gradient but positive and negative. And if you actually draw that, so a gradient of 3, a gradient of minus 3, you don't get anything near a right angle. You get you get an acute angle and an obtuse angle there. So it doesn't quite work that way. So some of you might be able to remember from GCSE. Perpendicular lines have what we call reciprocal gradients. Now, reciprocal is a really important word this year. You're going to see it in a few different occasions throughout your AS level. They have reciprocal. Now, reciprocal is basically flipping a fraction. So if you had gradient of, gradient of 2, the reciprocal of 2 is a half. And the reason why is 2 as a fraction is 2 over 1. So if you flip that fraction, you get 1/2. Now I said one's positive and one's negative, so if one gradient is 2, the other gradient, we can say perpendicular gradient, minus a half. So again, if our gradient, let's try another one, gradient of 2/3, perpendicular gradient would be minus 3/2. Cool, right, let's try a few of these then. Parallel and perpendicular gradients, parallel and perpendicular lines have negative reciprocal gradients. Right, G. So if you have y equals 2x plus 3, the negative reciprocal, or the gradient of a perpendicular line, so perpendicular y equals, flip the 2 half and make it negative. And the intercept, we don't know, there's many perpendicular lines, so we just put plus c there. Okay, another one, you might have y equals minus 7 over 8 x plus 5. So again, the perpendicular line, the y equals a reciprocal, flip it, 8 over 7. And it says negative, but it's already negative. They can't both be negative, or they definitely won't be perpendicular. So we're going to basically times it by minus 1, same as we did here. 2 times minus 1 gives us a minus. And we're going to change the sign from negative to a positive. So don't need to write anything there. Let's see. Right, one more example. This is nice and drilled in. If we have y equals 3 over 5 x plus 7, perpendicular line, going to be y equals minus 5 over 3 x plus 8. Now if you want to test if two lines are perpendicular, you can just multiply their gradients together, and the product is going to be minus 1. So product of perpendicular gradients is minus 1. So if we times 3/5 times minus 5 over 3, we get 15 over 15 and a minus, which is minus 1. And that'll be true for any of these. So if you want to try multiplying these together, get minus 1, or timesing these together, get minus 1. I've actually left out all the x's here, I just realised, so x there, and x there. Brilliant. Okay, so last bit is we're going to try and find some examples of lines that are parallel and perpendicular to other lines. So first one, we'll have y equals 7x plus 5. So can you find me an example of a line that's parallel to this and perpendicular to this? So pause the video quickly and do that. Alright, so for parallel, you could have anything that's got 7x, so y equals 7x plus or minus anything you like, so I'm just going to put plus c. Perpendicular, y equals, your gradient has to be minus 1 over 7x, and again, plus minus anything you like on the end. The number on the end doesn't stop it from being parallel or perpendicular. Cool. Right, one more of these. So, can you guys find a line that's parallel and perpendicular to the line y equals 2y equals 7x plus 3. So again, pause the video, find a line that's parallel and perpendicular to that. If you want, you can just put plus c on the end. You don't have to worry about the intercept. Right, so this time it's a bit harder. You have to rearrange it, so it's what we looked at the beginning of today's video. So first of all, we're going to rearrange this to get y equals, so divide everything by 2, 7 over 2x plus 3 over 2. So a parallel line will have to have a gradient of 7 over 2. Plus anything you like there. And a perpendicular line is going to be y equals minus 2 over 7x. If you got this one wrong, go back and have a look at the beginning of the video. You've just forgotten that you have to divide y, or have to get y equals mx plus c in order to read off the gradient. Okay, last one then. Combining everything that we've done so far today. Okay, so the last question, find the gradient of the line perpendicular to the line that joins these 2 points. So basically you've got 2 points A and B. We want to find the gradient of the line that's perpendicular to the line that joins A and B together. So give that a go. Pause the video, give it a try. If you are stuck, I will give you a hint in a second's time, but pause it now if you want to just try it straight away. Okay, if you're not sure how to start this, first of all, use our gradient equation to find the gradient of the line joining A and B, and then find the perpendicular gradient to that gradient. Right, so let's go through this quickly. So our gradient equation, remember, y2 minus y1 over x2 take x1. So put all our values in, so we'll say this is 0.2, this is 0.1, so m equals minus 1 take 2 over 3 take 8. You might have done it the other way around, doesn't matter, you should get the same answer. Minus 1 take 2 is minus 3, 3 take 8 is minus 5, so our gradient is 3 over 5 because the minuses cancel out of each other. So the gradient of the line perpendicular to that line is going to be m. We can put a little perpendicular sign there to show that it's perpendicular. It's going to be negative reciprocal minus 5 over 3. Brilliant. Okay, if you've understood everything and happy with all that, move on and try the quiz for this video. If there's anything you found difficult, go back, watch the video again, or ask me for some help before next week's when we're actually going to be doing all this work.